Hello and welcome to Ngwasheng Maths Online Academy. My name is Desmond Ngwasheng. I'm your maths tutor for this channel. This is part 3 of sequence and series. However, in this video, we only accommodate geometric. As you can see, we are doing anything geometric today, anything you can think of geometric, because the past two videos based on sequence and series, we were mainly focusing on arithmetic. There was the first video, part 1, which was like 22 minutes long, and then I decided to proceed and do part 2 of arithmetic as well, which was a continuous. So make sure you watch part 1, then you can go to part 2, so you can be able to link the two videos together. And now, since this is going to be part 3, we are doing anything and everything that is based on geometric. However, the main topic is sequence and series, but we'll be focusing much on geometric in this video. Whatever that we may not cover, I think the next video, which is going to be part 4, now I'm summarizing everything. But exam based, I'm gonna do the exam based question. I'll be specific that this question that I'll be doing, it will be made from November 2025 or whatsoever. I'm going to mention that. So basically, it will be exam question. That will be part 4. Now, make sure you subscribe, hit the notification bell, like, comment is very important, guys. And then obviously that will be the end. Once I do part 4, it will be the end of sequence and series based. However, there might be or there will be random videos that may be based on the same topic, based on the request, actually, on the comment section. If you request something, I'm gonna do it. So now let's focus on this now today. As you can see, it's geometric sequence and series. You can think of anything. As you can see, the general term is there, formula. We have a formula to determine the ratio. We also have two formulas that we use to find Sn, the sum of series. And then we also have infinity there at the end. We also have this formula that we use mainly to find the unknown value, especially when you're talking about the converge series. We're going to touch on all, but without any waste of time, let us firstly work with these 3 lessons. We're going to start with the basic up to the complex one. All right, now, if you can see here, the first lesson, we are having a sequence here that consists of like 5 numbers or 5 terms. Since we know that we are talking geometric. Now we have to think of any formula that is geometric based. Now that our lesson is strictly specific to say we are doing geometric, in exam at some point, all these formulas, they will be there. It's up to you to be able to choose the correct one. I know if they didn't mention what sequence is this, one will try to see, is it arithmetic or is it geometric? And we know formulas to do so. Now, let's start with the basic. Having this sequence, one can tell that you know the value of A, which is 1, as it is our first term. First term, second, third, fourth, and fifth. So the first one is always regarded as T1. We know this. We did talk about this on the previous video. So now, how to find R, which is the constant ratio. There is the formula. Whether using term number 3/2, we expect to get the same answer. But I don't have to verify that, as it is stated that it's geometric already. So now, what is the second term of this entire sequence? Is 2. I'm having a 2 there. But the first term, it happened to be 1. What do I get? I get a constant ratio of 2. Now, what if a learner used this just according to the formula? Let's see, term number 3 there is given as 4. However, term number 2 is 2. Now, 2 into 4 goes twice. I'm still getting the same ratio. Hence, we call it constant ratio. It doesn't change. It remains the same across. Furthermore, what if I say term number 4 divided by term number 3? Let's work on it. Term number 4, it happened to be 8 all over term number 3, which is 4. Now, 4 into 8 goes twice. Furthermore, term number 5. I can say term number 5 over term number 4. Term number 5 happened to be a 16 all over 4, which is an 8. It gave me 2. This proves that this sequence is actually geometry, because no matter what you do, you still get the same answer. When you say it's actually constant difference, you can see we keep getting the same answer. No alternate, same answer. So now, as I'm saying, this is the basic. One need to know this, how to get the R, because they're going to play a major role in everything that you're going to do here. And still having the A and the R, following this formula, they can now ask you to find the general term. Space, I don't have enough space there. General term, or let me bring it here. As long as I've got my A and my R, A and R, then I can just get a general term. And that's what they can ask you. General term means I don't know the n value. I only know my A and R are quantigeometric. So what is my A? In this case, A, it's 1. Let's say I put 1 there. What is my R? In this case, it's 2. What is n? I don't know. So 1 actually, it's nothing. So I can simply say this alone, this is my general term, which is known as the nth term. They like to use different terms, the nth term. Hence, this is the basic. Now, let's proceed to lesson number 2. Lesson number 2, if you check, we are having a sequence again, but it's a sequence that is given in a expression form. This is expression, 7x plus 1, it's an expression. Because of we do have this variable of x in between. However, this sequence was just given by means of like constant numbers. Now, I have 3 of them. Let's work on that. I have the first term, second term, third term, T1, T2, T3. Okay, now let's check what we have and what they want. Let me clear this space. You have this, and please make sure you know for a fact that I'm moving from one lesson to another. So you are welcome to pause and work out on lesson number 2. Immediately when you're done, proceed with 3, so that by the time I'm providing the solution for this lesson number 2, you are able to compare your solution with mine. Then if it is similar to mine, then we are winning. All right, now let me clear that. Let me clear so we can have enough space for more lesson. Make sure you subscribe, you like, you share, you comment. Guys, it's very important. And stop watching videos for only 10 minutes while the video is actually 20 or 60 minutes. You know, make sure you watch the entire video. I don't know how long this is going to take, but my aim is to cover everything. So imagine covering everything that will take almost an hour. Then you decide to watch for 10 minutes. What about most of the things that will follow? Because we know the nature of the lesson. We start with the basic, and the basic can take up to like 5 minutes. Then you are watching for 5 minutes while the video takes an hour. So basically, you didn't learn a thing. Because most of the things that are very important, the core part of this is when we proceed with lesson. And you cannot, once you skip, how are you going to relate lesson number 8 with lesson number 1? So basically, I just want you to watch the entire video. Now, if 7x plus 1 as a first term, 2x plus 2, x minus 1, form GS, guys, due to the space, GS, geometric sequence, determine the value of x. If you practice enough, you're playing your part very well as a learner. By looking at this, you already know what they want. When you read this statement, you can tell what is it that they want right away. So obviously here they're looking for the value of x. What does x represent? Now that we are talking geometric, learners need to know that we still apply what we're doing here with our ratio. The way we are finding a ratio, we still apply the same thing. So basically, we agree that term number 2 over term number 1 should be equal to when you say term number 3 over term number 2. It's a creation of formula. This helps us to create an equation because we cannot determine the value of x if we don't have equation. So this is a way of us creating an equation by following a method used for determining the ratio, just like we did with the previous one of arithmetic, where T2 minus T1 is equivalent to T3 minus T2. So we do the same, but we don't subtract. Actually, they divide because it's been influenced by the formula of determining the R. And then obviously, after writing this mathematically, you have to substitute. What is T2? T2 is 2x plus 2 over T1 is 7x plus 1. It's equivalent to, what is T3? T3 is x minus 1 over T2 is 2x plus 2. You can pause the video and work on it, then proceed with the lesson. All right, now, in this case, the easiest way to deal with this, especially to get rid of the denominator, we can apply cross multiplication method. Like, meaning I can multiply this numerator with this denominator, vice versa, right? So we just follow that. That is a way of like trying to get rid of the denominators. Let me write the result here. Never mind, this is not part of 2. This is not a part of lesson number 1. It's just a continuous. It's lesson 2. I just want to write on this side. All right. So when I cross multiply this and that, I'm having something like this, which is everyone is familiar with. And then obviously these two, the order doesn't matter whether I start with this followed by that, but the order doesn't matter. Properties of multiplication applies in this case. So now I'm gonna say, excuse my space, I'm gonna work on it. As a math learner, from here you celebrate, because this is just a plain algebra where you are applying the FOIL method, blah blah, simplify, whatever. So let's do it. So we are going to have Obviously, 2 times 2, 2x is 4. Then that, actually, let me just say, the middle term want to give us 8x. Therefore, the last part will just give us a 4. I already simplify. I know that if you follow this, do that, and everything, you'll end up with like maybe 4 terms, and then with 2 at the center that you need to group as like terms. Eventually, this is where you end. You're going to end up here. All right, now let's see. Same thing applies to this side. We've got 7 terms. That is 7x squared. We've got the last part will be a -1. Then the middle one will be a 1x and a -7x. That gives us a -6x. Yes. All right. Now, let's group like terms. Let's group like terms. I can take all these to the right. Since, well, 7x squared and 4x squared, 7x is bigger, so I'm avoiding negative by bringing it to the left. So instead, I'd rather take everything to the other side. Let's assume that everything has been transposed to right, but let's write them by means of grouping them together. So 7x will subtract 4x squared. Then I have this -6, which is going to subtract 8x. I have this -1, then joined by 4, which was positive, now negative. So 7 minus 4, that is a 3. That is a 3x. And then these together, they give me 14x. And then these together, they give me 5. Like, this is us getting the value of x. Actually, they like to say value or values. They put the, I forgot to identify them to indicate that. Because value can be maybe your result, you're getting 1x. Values is something that will be more than 1. So as a quadratic, we're expecting we're expecting two x values like that. So this one, let me say, because it's 3x, it's 3x there. Now, factors of 5. We've got only 5 and 1. Now, the position is very important. I'm going to do a video for the grade 10s and 11 based on factorization. This is going to be beneficial for the grade 12 as well, because we are always telling the grade 12 that most of the things that you did in grade 11, we are no longer teaching you, but you're going to be assessed with that. All right. Now, I know it's 5 and 1, but if you put 5 here, 1 here, now let's say 5 times, we are getting a 5x. If you say 3 times that, you are getting a 3x. If we add them, they give us 8. And I don't have 8 there. If I subtract them, I'm getting a 2. And I don't have a 2. So a lesson for factorization will follow. That means, it doesn't mean these factors are wrong, but the positioning of these factors. That means now I can switch them around and say, let me put a 5 there and a 1 there. So by so doing, let's double check again. 1 times x, that's 1x. 3 and 5, when you multiply together, they give you like a 15. So chances are 15 minus 1, I'll get a 14. Now let's check the sign. When it comes to verification of sign, obviously 15 should be negative, since, well, is the bigger one, 15 and 1. So how do I get 15? When I multiply a 3 and a 5. And obviously, a 3 is automatically a positive as the leading number. So I can make 5 to be a negative so that I can get a -15. And this one should be positive so that I can get a positive. So hence I'm saying there will be a separate lesson for factorization of a trinomial. So in this case, let's proceed. Remember, guys, we are actually solving for x under geometric sequence. So you must make sure your algebraic skills is on par. So now let's separate this. Obviously, as a grade 12, by now you should know this. So now this is me just working on it. Now, there we have values of x. That was the question. They wanted the value of x, and we gave them that. We have negative 1 over 3. We also have x equals to 5. Now, let's move to the next one. And they also like to say, after finding the value of x, they can ask you to find the first 3 terms, the values of the first 3 terms. That is when you can now substitute your x values to those expressions. Now, let's move to lesson number 3. So obviously, work on everything. I said pause. By now, I'm done with lesson number 2. I'm moving to 3. By now, you should be done with them, so that when I'm working with lesson number 3, you're already there waiting for the solution, so you can compare. And then from 3, obviously, I'm moving to 4. Now, let me create enough space for more lesson. All right. Comment, like, share. Don't skip the lesson video, guys. I know. Even my kids, they at some point, I'll be asking them, like I'm referring, even when I'm teaching, I can refer them to the videos, because I know whatever that they are asking, it was covered in the video. It shows that no matter you presented a 1 hour long video, some they will just watch 20 minutes and miss the rest of the important information and come back to ask some more. All right. Now, lesson number 3. Determine the number of terms in the following sequence. Now, the most important thing there, I said where there's a question, there's answer. Now, number of term, that's n. And the fact that the sequence that we're dealing with, it is geometric. We know that selection of formula is very important. So we're gonna take this one, t n equals to a n minus 1, ar n minus 1. We are now taking this and work with it. Understand that according to this, if I have to indicate what I'm given, I know my a, it's half, done. We are talking geometric, so I need to know my r. What is my r? It's term 2 divided by term 1. I can write that, indicate that. So following this, no, I made a mistake. Okay, let's sort it. We say term number 2, it happened to be 1 over 4 divided by term number 1, which is that. Yeah. Now, let's get our r. So 1 over 4 multiplied by, when we switch this, it's a reciprocal, it will become 2 over 1, which is, I'm still getting 2 over 4, which is equivalent to r. So basically, our r is also a half. What else do I have? I have, according to that, I have this. I mentioned on the previous video under arithmetic series or sequence that usually the last part here represents the Tn, the last term, the one that is forever on the far right. But be careful, because some they might seem to be Tn while they're not. So now Tn, that means now under the given Tn is also 1 over 256. 1, 2, 3 things. Remember, formula has 4 things here. 1 is the n, 2 is the a, and the third one is r, the fourth is Tn. So obviously, I have 3 of them, a, r, Tn. What's missing is n. Hence, they are asking for n. Be able to don't just rush to answer or solve problem. Analyze the given data. Identify what you have and what you don't. Then definitely you'll be doing the right thing going forward. That's my Tn there. I substitute. This is 256. What is my A? It's a half. What is my R? It happens to be a half too. What is my N? I don't know. Yeah, now from here, this is just maths. This is maths. Let's say I know from here, learners, they will just apply different method and still arrive at the same answer. That's what I like about maths and exponent, especially the exponent. If you look at this, we are having the same base. We can say let's multiply the same base and add their exponent. Showcase, we can still do that. But one can still remove this half by multiplying with the reciprocal. What you do on the left, you do on the right. So either way, the choice is yours. Which one you prefer? Let's say I prefer to apply same base law. Remember in grade 11 and 10, where you say when you multiply the same base, we are actually adding their exponent. Remember all this. Yeah, now they come in handy because basically this half has an exponent of 1. So if I multiply them together, then I have 1, this one, plus and minus 1. So I decided to apply that. Okay? Now, that means I can manipulate this. Like the whole thing, I can manipulate this to be the same as that. Even if, okay, now 1 minus 1, so I'm left with n. If you can check, this one already has been simplified. Now, the nature of this problem, they forces you, in most cases, to have the same base on the left and on the right. Then we can just deal with their exponent. Now, sometimes I'm telling learners, even if you are not sure of how to change this into exponential, but because it has to be similar, I can say, whatever it is, it must have a half. I rather struggle to get that number there. So whatever the exponent here, obviously it can be shared between 1 and 2 separately. Like you can check, if you say 1 to the power 2, whether you say 1 to the power 10, 1 to the power, the answer will still remain 1. For this one, I don't have to worry. But now let me check what is the exponential of 256? It's it has to be 2 to the power something, basically. 2 to the power something. I don't have a calculator with me nearby. I don't have. So I'm trying to get a calculator to work on that. Okay. But I can say, let's say we know to do whatever that comes first to your mind. If I say 2, like 2 to the power 5, that's 32. Sorry, why do I write that? That's 32. So if I say 2 to the power 6, that's a 64, meaning like it keep on. So I know for a fact to get 256, it has to be a number that will be above this. What is 27? That is 64 times another 64. I'm not sure. I don't have a calculator, but I can tell. Where is the calculator, basically? All right. There is a calculator. I found the calculator. So let us not waste time because I know wherever you are, you can just work on it. All right. So it appears that 256 is made of 2 to the power 8. Give us 256. Obviously, if you don't have a calculator, you'll struggle to get to the answer quickly. So now it's going to be 8. 2 to the power 8 give us 256. So a way to write that, if I put 8 here, what does this mean? It means this 8 outside can multiply with the exponent inside. having a numerator and a denominator, meaning they can share the same exponent, which is out. So basically it's like 1 to the power 8 and to the power 8. We do have this exponential law, meaning if I do this, you see they are the same. So it's better when you're writing one of them like I did, because no matter what, 1 to the power 8, like so 1 times 1 times 1 up until like they are 8. So in this case, don't forget that we are not dealing with exponent. We are still doing geometric. It just happened that when we're dealing with geometric, you are going to experience exponent like this. So therefore, since these are similar, then our answer n is equivalent to 8. Done. N is equivalent to 8. So let's make sure that we move fast so we can do most of the problem. So far it was only these 3. I'm gonna make sure that I become fast for the next course. I want to make sure that I reach all this, everything. So make sure you pause if you don't understand, you work on it, you rewind, you go back, or you rewatch the video. That is because obviously the nice part about video, you can rewind, you can pause, you can fast forward, everything. Unlike in a classroom situation. All right, let me proceed with lesson number 4. Let's do lesson number 4. Comment, like, share. All right, now let's do lesson number 4. We did some equation under arithmetic sequence. We also have equations under geometric. So now this is going to be based on equation. So we can see if you want to relate with what you're doing, as this is part 3 of sequence and series based on geometric, go and check part 1 and part 2, and see how do we deal with the equations under arithmetic series or sequence and series and arithmetic. Now, in this case, the most important part of equations within geometric sequence is to be able to convert this information and present it in an equation form. Remember, in algebra, we are forever given equations to solve, ready-made equation. But here, they give you equations in a word form, like linear programming kind of a thing. Now, we say, check what you have. They say 4th term of a GS, again, geometric sequence. 4th term of geometric sequence is 16. That is the equation, because 4th term is T4. So term number 4 is actually 16 over 9. While the 10th term is that. I don't care about the question itself. I can just sort out this mess, work on this. So now let's start. Let's indicate this. Let's write this in equation form. Firstly, I'll say T4, it's 16 over 9. And then I've got T10, which is 81 over 4. My marker is weak. Now let me take these two as normal equations. However, to create the normal equation, I must consult the general formula. As you can see, the position there, n, happens to be a 4. But again, that T4 is equivalent to 16 over 9. I don't know my A, I don't know my R, but I know my N, which is 4. So now, let us substitute what we have. According to the formula, I will say, now, since they say T number 4, what is A I know. What is R? I know. What is N? Is 4. So it will be 4 minus 1. 4 minus 1. So basically, just write a 3. And furthermore, tell us what is T4. As it was stated, you can see is equivalent to. So I'm going to say basically my AR3 is equals to 16 over 9. Now this alone is my first equation, a proper equation. I created this by consulting a general formula using what I'm given. Imagine I'm going to do the same with this. Monkey see, monkey do. Right? So, like, I can create this one by just looking at the first equation. Hence, monkey see, monkey do. So, T10 is equivalent to AR. And there's a pattern of some sort. Since it's 4, it's going to be 3. Just go down by 1 unit because of this. If it's like here, 10 minus 1, it's going to be 9. So since it's 10, here it's 9. The power of practice, you end up seeing such things, so you don't even have to go a long way, always. So now, let's take it to the from this rough equation to a proper equation. What is our T10? T10, it is stated to become 81 over 4. It's equivalent to 81 over 4. But let me write this as AR9 equivalent to T10. Where my T10 is what? 81. So I'm going to put 81 over 4 and label this as equation number 2. Just like in algebra where we are dealing with simultaneous equation, even here we are doing simultaneous equation. But you should remember how we solve this under arithmetic. We use elimination method. However, you are welcome to also apply substitution method. Does the same case apply with geometric? Let's work on that. Now, geometric, because we are dealing with exponent, somehow we cannot say equation 1 minus equation 2 or equation 2 minus equation 1. I know mathematicians out there, possibly they can work on it until they eventually get an answer. But to accommodate the grade 12, we always look for something of their level and something is more simpler and understandable. So we prefer to divide 2 equations. We simplify by dividing the 2. Let me bring it here. Okay, and then when we divide them, be careful. Are you saying this divide by that or vice versa? I can say 2 divide by 1. Oh, my marker is failing me. My marker is failing me. Let me get. Okay. Okay, so I prefer to say 2 divided by 1. So since I say 2 divided by 1, I'm referring to equation number 2. Equation 2 divided by equation 1. So let me write equation 2 on top, which is AR9 equals to 81 over 4 divided by the smaller one. I prefer to put it here. But I know the answer will be the same whether you prefer either way. As long as you don't make mistake, we have to get the same answer. So you see, under algebra, when we're solving simultaneously x and y, the method that we are using that side or on that topic is basically substitution method. On arithmetic, we can use substitution or elimination. I think this one is also part of elimination, but by means of division, simply because of this. Check. When we divide, basically, we experience cancellation. You can only cancel if you divide. But cancellation means, what does this come from? It comes from our exponent. Law number two, where we say when you divide to the same base, we subtract their exponent. So it comes from this. So hence we just decided to cancel. We already eliminated. So we avoid to have two unknown variables to solve, at least one variable at a time. So when you say equation 2 divided by equation 1, we try to eliminate one of the variables. Definitely, I'm remaining with R9 and R3 together with these numbers on the right-hand side. So again, applying exponential law, when you divide the same base, subtract their exponent, that means I'm going to say R9 minus 3. So what do I get from here? I'm getting R6. So right hand side, I know you can just punch a calculator as it is just to simplify everything. I don't have a calculator with me. I'll do manually. Or even if I do have a calculator, but I always prefer, let's say now I'm having two. So I'm just going to plug the answer when I'm done. But like 81 over 4, due to this division, we change according to bottom mass, we change that. And then if we change the sign, we're also going to switch numerator and denominator, vice versa. So I'm going to say 81 over 4 multiplied by, that's going to be 9 over 16. Yes. So that will be uh, a way to work with something of that nature. So what is 81 times 9? Okay. I'm not trying to be smart here. I just have to make sure this is for accuracy reason. Imagine this video reach 1 million views with the wrong answer. Yo, I cannot afford that. So this is for accuracy reason. Yes, there. So that means to work out the whole thing here, it becomes 729 over 16. And we know that since my exponent is 6, whatever I get here, I must also have the exponent of 6. That is, you can simplify 729 over 64, change that into exponential form. That is what I'm talking about. So if you work your thing correctly, you're gonna get 3 over 2 to the power of 6. Now that I've got a 6, I knew that eventually, because there was a problem that we did before this one. Don't remember which lesson was that. Maybe it was lesson number 4 or 3. I don't remember. We are forced at some point. Now, if you check, our exponent are same. Therefore, we can get this as our answer. You might feel like, okay, I'm done, because it seems like we did a lot. Are we done? What was the question? What did you get so far? Going back to the question, determine the oh, they are looking for term number 8, my good people. They are looking for term number 8. What we did, you only get R, and I cannot get term number 8 if I don't know my A. The purpose of working with this for the equation, we need to know the A and the R. So far, the R is covered. Let's find the A. Arise, what will be the use of getting 8 if I still don't have the A and R? Remember, to get the general term of 8, if I just put 8 here, that is a general term because I don't know my A and R. So this is a way of getting it. Now, how do you get the A since now we've got the R? We have to take R, this R, substitute back to one of your equations, and the choice is yours. Whether you use equation 1 or 2, the answers will still be the same. So I advise learners to always look for the simpler equation. You are not proving any point in examination. You want to pass. Because if I think when I take the one that is more complex, the time that I'm going to spend solving this instead of that one won't be the same. So let me choose this one of first equation, AR3 instead of AR9. Margin 16 instead of 81. So like that's what we do. So let's rewrite equation. I know this is messy, but if you follow me, you won't get lost. But those who are forever skipping, you won't even relate here. So now I don't know my A, but for sure I know my R there. Instead over 2 with a cube. That side we are having is 16 over 9. Let me clear um, the equation part because you already know that we managed to find the equation. I'm preparing to answer the actual question. Guys, if this take 1 hour without finishing some of the important aspect that I want to touch here, then I'm going to do part 5, which will be a continuous of geometric. All right, now let's come here. What is 3 cubed? Basically, let me write on the other side. That's 27. What is 2 cubed? That's 8. So I'm having 27 over 8a. That side I'm having 16 over 9. How to get rid of 27? Just to get a. We multiply by a reciprocal. That's going to be 8 over 27. What you do on your left, you do on your right. Now cancel, cancel, cancel. You are left with that. Now, just go crazy from there. Play with numbers. I'm calculating that on there. We say 16 by 8. I'm getting a 128. And then 9 times 27, I'm getting a 243. That's my A and my R there. A and R. Now let's answer the question. They wanted T8. According to the formula, it's like something like this. If it's 8 minus 1 is going to be 7. Now, what I like is that I know my A, I know my R. So what is my A? 128 over 243 multiplied by your R. Your R is going to be 3 over 2. Like separately, everything is going to be to the power 7. So that means now, let me simplify. What is 3 to the power 7? Okay, we're going to work on that. 3 to the power 7. What do we get? 3 to the power 7, I'm getting 2187. I'm getting 2187. 2187. However, what about 2? What about 2 to the power 7? I'm getting a 128. So if you check something here, if it allows me to cancel similar numbers, I will do that. That is a way of simplifying. So after canceling this and that, I just remain with, oh, I'm left here with 2187 over 243. Now simplify that. So how many times does 243 goes into 2187? All right. I'm getting that T8, the 8th term, is 9. Wow. Yo, for all that, just to get a 9. Term number 8 is 9. We have to continue. I think now the video is somewhere around 50 minutes. So let me now engage with something. I haven't touched the geometric series yet. I haven't touched the sigma notation based on geometric, but I think that is the only two things that are left. I'm dealing with the key, the core part of geometric sequence. And obviously the series, if I didn't touch the series, that means the use of this formula, we haven't applied them yet. And then obviously the infinity, the sum of infinity, the converge series. So I still have to apply them. But let me do the next lesson. All right, let me work on the next lesson. Then I will see where it takes us. If I spend an hour, maybe maximum 1 hour, 20 minutes. Yeah. I'm trying to cover everything that is very, very much important. But if not, I'm forced to do another part, which will be part 5, which is a continuous of geometric sequence and series. All right, let's continue with lesson number 5 and 6 and see where does this take us. If we can be able to finish everything here, because it's already 15 minutes. All right, my target was at least 60 minutes. All right, lesson number 5. In this case, you are given a sequence that consists of variables and numbers at the same time. Variables, as here you can see, they used P and Q. They can still use X and Y. So is 4, is P, is Q, is 13,5. And then they say this sequence is actually a geometric sequence. Again, GS, geometric sequence. Now, determine the value or the values of P and Q. So if you observe closely, it seems like every time they are looking for something missing, we are forced to create equations because we have to solve. We have to solve. So let's create equation. Unlike what we have in lesson number 5, lesson number 4, the previous lesson. I need to find P and Q, definitely. It is my duty to create what we call equation. Now, let's create equation. Where do we start? Looking at how many do we have? We've got term number 1, term number 2, term number 3. The whole thing is term number 4. Differentiate. If you can see, this is not the same as that. So that means this one regarded as a single number. They go together like it's like a 13,5. It's not like it's 13 and then followed by 5. It's just 13,5. Now, where do we start? Let's start with what we have, the obvious case. We know that due to having our general term, we can create equations. So now what I'm sure of is the first term. So if I say to you, term number 1 equals to 4, or rather I say equals to A, that means A is 4. It doesn't stop that. This is still an equation, basically. I say let's deal with what we have. I know another value that I know is actually this one of term number 4. 1, 2, 3, 4. So let me create term number 4. Term number 4, according to this, is AR. Where there is N, we're going to put a 4. So it's going to be a 4 minus 1 is 3. So, but what is term number 4. Term number 4 is 13,5. That is like my equation 2. So I'm going to deal with this part here. So just like the previous one, I think there's something obvious now. Where there's A, we can put 4 straight. So I'm going to have 4 here times R is what I don't know. It's equivalent to 13,5. Mathematically, I must get rid of 4 first. What does this mean? Actually, I can remove this by that and say a cube root of 13,5 over 4. Or one can just simplify this. Whatever you get, you're still forced to put. In this case, this is where I'm just going to use calculator because obviously I'm saving the time. Now, according to the calculator, I'm getting a 1,5. Can verify, comment, so we can talk about all these issues. All right, now that we've got A of 4, R of 1,5, this is the key. Like I said from the beginning, even in arithmetic, we know A and D, they play a major role. Same applies to A and R under geometry. They play a major role. Together with the consultation of this formula. Now, I've got A and R. I can find anything. So look, the position of P and Q. P is actually term number 2, while Q is actually term number 3. Use these to create equation for term number 2. That is you trying to find P. So it says T2 equals to AR. We agree that term number 2, according to this, if I put 2 here, 2 minus 1. So it's going to be just 1. I don't have to indicate that. So term number 2 is actually AR. But what is term number 2? What is the position of, what do you find? What is the term 2? It's P. P is in a position of term 2. So basically, T2 is equivalent to P. So when there is T2, let's put P. There's my P. I'm trying to find P. It happens that now I know my A and R there. So basically, what is P? Is 4 times 1,5. Yeah, calculator, 4 times 1,5, we are getting a 6. So basically here, our value of P is 6. We can confidently write 6. It was missing. Now let's find Q. I think now you can see that we follow the same thing across. That means look at the position of Q. Term 1, term 2, term 3. Q is basically in the position of term 3. Let's create equation of term 3 using our general formula. Term 3 is AR. Where do I get this? I'm still consulting this. Is AR n minus, what is n? N is 3. So 3 minus 1, that's going to be a 2. What is, we agree that term 3 is in the position of Q. So let's replace T3 with Q because that's what we want. What is A? A is 4 still. Multiplied by what is R? R is 1,5 squared. Now, punch your calculator or just do your maths. So we are getting, let me see, 1,5 times another 1,5. We're getting a 2.5. I mean 2/4, and then 2/4 times a 6. What are we getting here? What did I write there? Let's verify something there. Q. Oh, my mistake. 1,5. Let me just check that. 1,5 squared times times a 4. Yeah, it's okay. I think I punched the wrong answer. Now we're getting the value of Q as 9. Yeah, I punched a wrong number, so hence I got a funny solution there. So now it is proven by means of calculations that P, which is the second term, is actually 6, and Q, which is the third term, happen to be a 9. What I like about this kind of problem is that you can also check if your solution are correct. How so? Term number 2 divided by term number 1 must give you the same answer as you say term number 3 over term number 2. So I can prove by saying 6 over 4 should be equivalent to 9 over 6. I'm saying term number 2 over term number 1, term number 3 over term number 2. They are all equal to, only 3 can go here twice, here 3 times, so it's a 3 over 2. Here I can use a 2 as a common factor. 2 can go here twice, but here 3 times. So it proved my P and Q values to be correct. So let's go and do lesson number 6 now. Let's move to lesson number 6. However, we are experiencing a long lesson that is an hour, but I'm left with few serious problems that I want to also share with you. Like I said, if it happened that the video is longer and I didn't reach everything that I want to do here, I'll be forced to do another lesson, which will be part 5. It's a continuous of part 4. All right, let's do lesson number 6. Determine the sum of 9, 3, 1. Determine the sum of 9, 3, 1 plus 2, 7 terms. So let's understand. Is the red marker or the blue? Let's understand the nature of these problems. That basically they are forever slightly different. They've got different approach when you're solving for them. So there's a difference between when they give you a series like that and the last number on the far right, which is known as the last term. But now it's presented by means of 9 plus 3 plus 1 plus 2, 7 terms. Now we don't consider this as the last term. It's actually referring to n number of terms. And they are looking for the sum, that's Sn. And we've got the first 3. That means you already have an A, which is 9. And we can get R, which is 1 over 3. Look how fast that is. Now, what is it that we want here? They want the sum Sn. I have A, I've got. Now, here are the formulas. Between these two formulas, it was said that if we are having the R, which is less than 1, this is the preferred formula to be used. If the value of R is less than 1, obviously 1/3 is less than 1. So this is the preferred formula. And it was stated that if the R is greater than 1, this is the most preferred formula as well. But mathematically, you can work on, you can, like, you know, those learners who are very much curious. If you are a curious learner, your spare time, use it to check. Even if you use this one, use another one and see the answers. In most cases, it says the answers are the same. Hence, I say it is preferred. It is preferred to use that. I think I must come to the end of the video since, well, I think my mic is out of the battery now. Okay, now let's quickly do that. Now, due to the battery of my microphone, so my A is 9. My R is 1 over 3. Sorry, my N is 7. So that's a 7, and that would be like 7 for only that part, and then we've got 1 minus 1 over. Yeah, the sum of this means the sum of the first 7 series. The sum of the first 7 series. If you punch your calculator, you must get this. Now, guys, I noticed that I have to charge my mic, otherwise I'm going to have a problem where we'll have a poor audio. So let me end there. If you like the lesson and you did understand most of the things that we covered, now I'll appreciate and I'll advise you to subscribe for more lessons to follow. Share the video, share the link, comment as well. I need to know what is it that I can help you with. Meaning, you are welcome to comment on the comment section. That is the most effective way for communication between me and yourself. Thank you for watching. That means the next lesson, it's a continuous course. Now I think I covered almost above an hour, and as you can see, with lesson number 6, I just started with the series. So it means if I'm here, I'm going to do like this too. So it means part 5 is coming soon. I thank you.